Lot of disturbance, lot of disturbance, ma'am. You can start. Okay, ma'am. Okay. Life is a chemistry. Dilute your sorrow, evaporate your worries, and filter your mistake, boil your ego. You will get the crystal of happiness. So a very good afternoon to all. On behalf of BBBS, Akamadevi, Women's Arts, Science and Commerce College, Bagalkot, myself, Pooja Atsari, Lecturer, Department of Chemistry. I heartily welcome you all to this live webinar on Chemistry Daily Life, organized by Department of Chemistry. Now, I would like to call Srimati S. Patel Ma'am, Principal of our college, to welcome all the dignitaries. Over to you, ma'am.
Thank you, Pooja. Namaste. Very good afternoon to all. It's my immense pleasure to welcome you all to this live webinar on chemistry in daily life, organized by IQAC and Department of Chemistry, BBS Mahadevi Women's College, Bagalkot. On outset, I congratulate the organizer for organizing this beautiful webinar. So, chemistry is a present in everybody's life. It is every aspect of life is chemistry. So, chemistry is a wonderful subject and is very important. We all are made up of chemicals, and everything around us is also made of chemicals. Whatever we see, taste, or hear, or touch, all involve the chemistry or a chemicals or a chemical reaction or chemical interaction. One can easily observe the chemistry in different states of human life, such as in the food, the preservatives used in the food, the color, odor, and even the air we breathe, the various cleaning agents we use. Even very important is the human health and emotions that sometimes the result of chemical reaction within the body. So this is one of the beautiful subjects. To give more insight on this topic, today we have the eminent person, the young scientist awardee, today's speaker and the resource person, Dr. Prashant Adakati, Assistant Professor, Department of Chemistry, STM Art, Science and Commerce College, Vehicle. So it's my great pleasure to welcome you, sir. On this occasion, I would like to thank our management committee, the chairman D.V. Sangha and the sitting MLA of Bagalkot, Dr. Vijayana P. Charankumar, and the honorary secretary of D.V. Sangha, Shri Mahesh Nadni, and the chairman of College Governing Council, Shri Gurubasava Surivami sir, for extending their great support to organize this event. So I also welcome all the academicians, the faculty members, students, and the research scholars, and all the delegates who have joined this webinar. I wholeheartedly welcome you all and make use of, and who are non-science background, who are thinking of chemistry is not our subject, but it's it's a part of the nature. Nature without chemistry, we won't be there or nature won't be there. So we should understand that and make use of this webinar. I welcome all once again. Okay, thank you, Pooja.
Thank you, ma'am. Now, I would like to call our chemistry department HOD, Srimati Sridhara S. Murgod ma'am, to introduce today's resource person, Dr. Prashant S. Adakati, Over to you, ma'am.
Yes, thank you, Pooja. Good afternoon to all. I'm Srilata Murur. It's my great pleasure to introduce the young and distinguished guest of honor and speaker for today's live webinar, Dr. Prashant S. Adirkatti, the Assistant Professor, Department of Chemistry, SPM Arts, Science and Commerce College, Eton. Sir has completed BSc graduation in JSS College, Harvard in the year 2010 and his MSc post-graduation in PC Jogging College, Hubli in the year 2012. After that, Sir has secured PhD in Bangalore University and the postdoctoral in Indian Institute of Science. Sir has published 41 international peer-reviewed articles and 10 book chapters. Along with this, Sir also worked as a referee for international peer-reviewed journals and he is the member of editorial board. Sir recognized and awarded in the international level as international and scientist in this year only. So we are really proud to have you sir on this session. We are really lucky to have such an eminent resource person for today's live webinar. So hope you all utilize this webinar. Thank you, sir.
Thank you, ma'am. Now, I request Dr. Prashant S. Adirkatti, sir, Assistant Professor, Department of Chemistry, SVM Arts, Science and Commerce College, Ipkar. Now you can start the session, sir.
Yeah, thank you very much for all of you, especially principal of the Akamadeva Women's College, as well as Pooja, then Srilata Murur ma'am, for giving me the to present views on this particular topic. So now I would like to share my few thoughts on chemistry in daily life. So now I would like to share slides for you people. Let me know if you can see my screen. Hope you can see my screen, which I'm sharing right now.
Yes, sir. It is visible, sir.
Yes, sir. It's visible.
Fine. Yeah. Yeah. As soon as we hear the word of chemistry, especially the thing or the moment we imagine that in front of our eyes the picture has come, that the beakers, flasks, then color of the solutions, then again beakers. These are the various things which really comes in front of our eyes. But mainly, we need to understand the smallest particle or any particles or any molecules which contains a very minute, is a particle. So that is made up of, or what we can call it as atom. So that atom contains the various components like neutrons, protons, as well as electrons. Hope you can see from this screen. You can see if you are talking about atom, we'll definitely will be finding the presence of electrons, which are located in the orbitals, and within the center of this particular orbital, we can find the presence of protons as well as neutrons, which we call it as, nucleus. So within the nucleus, neutrons as well as protons will be present, and in the orbitals, we can find the presence of electrons. And the beauty of this chemistry lies within the electrons. So electrons plays a very important role. So before that, I will let you explain what exactly chemistry. Because the first question comes, chemistry means how one exactly, or how we can define the chemistry. Chemistry is nothing but what? The study of compositions, structure, properties, and reactions of matter, essentially of atomic and molecular system. Means, if you take any matter, so as already given few points about matter, that matter is nothing but what? Mass that occupies space. Again, mass versus weight. If we look into the main part of this matter, means mass versus weight. Mass is nothing but what? Amount measured in international system units, measured on a kg scale, and mainly this does not change with the force of gravity. So that is mass. as well as weight, a measurement as a result of gravity. This does change with the force of gravity. So now we got a little idea about what exactly chemistry is. Chemistry deals with the matter that really occupies some space, and of course what all changes takes place within the substance or compounds or any mixtures. This is all about, we are going to call it as chemistry. And overall, whatever the change is going to take place, it's exactly, or it is mainly rely upon the electrons. So these electrons really plays an important role. So this is all about a bit definition about your chemistry. Again, again, we're all like, why chemistry is so important? The first question comes in our mind: why chemistry is so important? Why do we study chemistry? And what is the role of chemistry in life? So if you really understand this concept, we really, overwhelm. So we all are made of chemicals, and everything around us, as Principal Man has already told about, we can see the presence of chemistry around us. How? Like you can see from this slide, everything we hear, see, smell, taste, and touch, and touching involved chemistry as well as chemicals. So these all things we usually find around us only. Again, hearing, seeing, tasting, and touching all involve intricate series of chemical reactions as well as interactions in our body. So many of the changes we observe in the world around are caused by chemical reactions. So as I told, chemical reactions are nothing but what, the playing of electrons, or between the two molecules or the two compounds. Some many displacement reactions takes place. The name chemical we have been given because there is a presence of some bonds, like ionic bond, chemical covalent bond, for dipole-dipole interactions will be there. So because of that reason, we have given name as chemical reactions. As well, chemistry is also not limited to beakers as well as laboratory. It is all around us, and the better we know chemistry, the better we know our world. So for this, I will give a few examples. So now, nowhere I will go, apart from human body. We can find the presence of chemistry in our human body itself. Human body itself, in terms of elements. Now, so now we are now amazing because we ourselves, like the human body containing a lot many elements, almost plenty of elements we can find in our body. And the first thing is, most of the human body is made up of water, with a cell consisting of 60 to 70% of water by weight, as well as mainly 99% of the mass of the human body is made up of mainly six elements. What are those elements? If you look into the elements which are constituted by the human body, first one is oxygen, then carbon, then hydrogen, nitrogen, calcium, phosphorus. So these are the various elements which are present in the human body, along with these elements. So these all comes under periodic table only. And of course, this is not away from your chemistry. This all comes in under the category of chemistry only. And apart from these elements, we can find various elements too in our human body. Like you can see this one. So 65% of oxygen is, human body is made up of 65% of oxygen, then 18% of carbon, then 10% of hydrogen, 3% of nitrogen, and others will be present over here. And the respective table is represented in front of you. Oxygen is present this much percentage, carbon like that. So mainly if you see this chart, oxygen is 65% will be there, and very less amount of emission. So these all elements plays a very important role. If any of the constituent, or if any of the one element is not working properly, means that leads to some other diseases. So mainly, my talk of today's talk will be containing two aspects. Sorry. One is fundamental aspect, another is applied aspect. Means whatever the thing which I'm going to cover now, that will be very fundamental. Means we can see where all we can see the presence of chemistry, or where all we can see the compounds or any chemicals which is present in our day-to-day usage of any of the substances. So, and the next is I will be talking about some applied oriented, like if, as I told you in this slide, if any of the element which is not working properly, means that leads to disease. How one can determine those diseases? So for that we need to do some research or apply part. So mainly, as I told you that, it will be two sections. One is fundamental, another is applied oriented. So now let us see fundamental aspect. Fundamental aspect in the sense, as soon as we wake up in the morning, we use toothpaste. Better no need to explain about these things. Of course, we can see the chemistry over there, right? Like it's the mixture of chloride, peroxide, and baking soda. So these are the three mixtures which we can find in a toothpaste. Again, if you take in the toothbrush, again needles you can find over here. These needles are made from polymers like nylon, any other things. But it is part of this chemistry. Again, we can see any mugs as well as buckets, and these are made from polymers itself. So now we may wonder, okay, chemistry is around us, not only around us, we are using day to day in our life. Okay, so again, once we got fresh, then we used to take coffee. Because if we have coffee again, we feel very fresh. Why? What is the reason? The reason has to be there, right? Because coffee keeps us awake because the presence of chemical called adenosine. So adenosine which will be present in the coffee, and that makes to not to go for sleep or we feel very fresh. Like it binds to certain receptors and slows the nerve cell activity when sleep is signal. So this is the reason if you take any coffee or tea, we feel very very fresh in mood like that. Again, you take a simple example, onion. Better probably nobody is away from this onion because if you visit any kitchen, definitely we can find this at the kitchen room. So when we are chopping this onion, definitely probably we all experience this one. The eye is going to get irritation, is going to get sharp. And what is the main reason for that? Because only one reason, this onion contains sulfur. Sulfur is a chemical component which is present in the uh, onion. As soon as sulfur is going to react with a water molecule, because in our eyes there is some water kind of moisture will be there. When it is sulfur is going to react with watery kind of moisture with our eyes, what happens? There is formation of sulfuric acid is going to get formed. So this is the beauty of chemistry. Sulfur is going to react with the water molecule, like which is there in our eyes, as well as the moisture also. Moisture in our atmosphere, moisture content will be there, like little bit part of the water molecule we can find. Sulfur as well as water molecule is going to react with each other. They are going to form as a sulfuric acid. So as you know that sulfuric acid is very irritating in nature, and that's why our eye, like the sulfuric acid burns, stimulating your eyes to release what more tears to wash the irritant away. So this is the beauty of chemistry lies within the onion. Now see another point. Can you see this slide?
Yes, sir.
Okay.
No, it's not good for this.
Okay. Okay. Sure. Right. Oh no, it is visible.
Yes, sir.
Okay. It is visible, right?
Yes, sir, it is visible.
Yes, yes. Okay, once again I will come back to the kitchen room only. I won't go, from out of the kitchen room. I will be there 1 more minute in kitchen only. So again, in kitchen room also we can see the presence of chemistry. Again, if you see the example of this cooker, pressure cooker, there also we can find the chemistry because as you can see from this, slide that there is a pressure cooker. What happens when we heat it? The water molecule or the water which is present in this pressure cooker, it will get start to vaporize, is going to get stuck. That vapors will not go out from this pressure cooker because the lid has completely covered in this cooker. So that's why what happens, the pressure has been induced by the vapors. So thereby what happens, the rice which is present inside this vessel, it is going to get boiled. So thereby what happens, the meals are cooked very faster in pressure cooker. So again, here also we can find the presence of chemistry. Again, so salt, once again NaCl. So That is also the table salt, which is containing what sodium as well as chloride. Mixture of sodium and chloride gives us a table salt. So here also we can find the presence of chemistry. Again, vegetables. So we can see from this slide that you take any vegetable, all vegetables are like color. Especially you take a tomato or any carrot or any other thing, cucumber. Like what happens there, we can easily see that what are the presence of various colors. What might be the reason for the color? That is also now the question comes in our mind. The main reason for that one is presence of carotenoid. As we can see, many vegetables and fruits are strongly colored because they contain a special kind of chemical compound named carotenoids. So what happens when the carotenoid is present in particular, especially this is present in carrot. When this carotenoid is present, so because of presence of carotenoids only, it is going to show its individual color. So here also, because of presence of carotenoid, that is chemical compound, the price of carrot is like that. Again, the chemistry is not only related or very restricted to only one thing. As from this slide, we can see chemistry. We can see chemistry in almost all kind of fields. From clothes, cooking, food, in soaps, in batteries, in petrol, in concrete, in paints, papers, plastics. Everywhere we can see the presence of chemistry. So now we may get wonder. So daily we are using all this kind of stuff, but we don't know the chemistry lies within this, domain. Now we'll talk about only the chemicals of food in everyday life. What exactly, as Principal Ma'am told that we are using some coloring agents for our foods and all. Same thing, we'll explain over here now. Chemicals of food in everyday life means what all the peoples are using for making the food very attractive and very tasty, and in order to prevent the degradation of the particular food items, and how the minerals would be added, especially to the water. Because if we purchase any water from any shops, we feel somewhat different kind of sweety kind of taste, right? Because of the presence of minerals. There also we can find the presence of chemistry. Now let us see one by one how exactly coloring agents will be used in food, how artificial preservatives will be used, how artificial sweetness and antioxidants. We'll see one by one. If we see this from this slide, one can see here all, like you take the food coloring, take any go to bakery items, take bakery items where they are using any some coloring agents, or we can call it as a food coloring. Again, if you take flavor enhance, definitely one or the other we people will be using this kind of things in day-to-day life. But in this all, we can find the presence of chemistry. Now, again, if you are taking food additives, so food additives are substances added to food to preserve flavor or improve its taste and appearance. So because of, in order to preserve their flavor as well as improve taste, the food additives are going to be used. Some additives have been used for centuries. For example, salting or using sulfur dioxide as in some wines, and many more additives have been introduced of both natural as well as artificial origin. If you talk about only artificial preservative, these prevent spoilage of food by stopping the growth of microorganisms. For example, sodium benzoate, sodium metabisulfate, they are put into use. So, in artificial preservative, we can find the chemical compounds that is sodium benzoate as well as sodium bisulfate. Again, if we talk about artificial sweetness, these do not impart any calories to the body. Means this is actually it is occurring naturally, but we are simplifying in the laboratory in order to enhance the taste or in order to enhance the sweetness of the particular compounds. But that is not going to provide any good things to the body. In such a way that it is not going to impart any calories to the body. Since the substances are excreted through urine, for example, like I can give aspartame as well as allicin. So aspartame is the one it is used in cooling and ice creams, as well as as allicin. It is 2000 times sweeter than sucrose. Especially allicin we can see in the bakeries. So liquids we are using this adenine. Again, one more thing is that antioxidants. So these all antioxidants we can use in the food items. Why one has to use this antioxidant? What is the main role of this antioxidant? The question comes in our mind. So these prevent the spoilage of food by preventing the oxidation of food. For example, sorry, butylated hydroxy tolerance as well as butylated hydroxyl anisole. So these are the two antioxidants which are mainly used to prevent the spoilage of the food from the oxidation. Best example I can give, you just chop the apple and keep for a few minutes. As soon as you keep for a few minutes, say for example not more than 5 minutes, the from white color to brown color is going to get oxidized. Means because of oxidation, what happens? The color of the apple is going to get changed from white to brown color. In order to prevent not only apple, take any of the other edible items. So there we are using antioxidants. Mainly the component of these antioxidants are BHT as well as BHA. Again, if we talk about uh, coloring of the our daily wears or any of the textile. So there mainly dyes are color organic compounds that are used to impart color to the various substrates, including paper, leather, paper, cosmetics. Again, dyes are classified into natural dyes as well as synthetic dyes. So these dyes are, in one word, I can tell you that dyes are used to give the color. Especially in the textile industry, we are using this dyes. Of course, in paper industry also we are using this dyes. There also we can find the presence of chemistry. So now, if you talk about artificial wash the sweetener, the chemical formula or the chemical structure of this artificial sweetener, that is saccharin, is entirely looks like this. There we can find the presence of certain number of carbons here and certain number of hydrogens and sulfur, nitrogen, oxygen we can find. So saccharin, as I told you in the previous slide, that it can be used as an artificial sweetener. So it is about 550 times as it as cane sugar, and it is excreted from the body even unchanged. So this is how the satin can be used as artificial sweetener. Again, aspartame, as I told you that aspartame is also one of the chemical compounds which can be used. So this aspartame containing the two molecules. One is aspartic acid, other is phenylalanine. So this phenylalanine and aspartic acid, from both these things, one can prepare the aspartame as a sweetening agent or as a sweetener. So it is a methyl stuff diseparate form from aspartic acid as well as phenylalanine. So this is all about what artificial sweeteners. Now we talk about antioxidant in order to prevent the food from the oxidation. One can use, as I told you, butylated hydroxytoluene. So exactly the butylated hydroxytoluene looks like this. The structure of it contains benzene, and we can find the presence of hydroxy, and we can find the presence of alkyls. Here tertiary alkyl TCS3. This is what tertiary alkyls. So this is the structure of what? BHT. Again, what happens? One more example, in order to prevent the antioxidant, we are using PHA, butylated hydroxy anisole. This is the chemical compound structure of the PHA. Here we can find the presence of hydroxy. Again, we are finding the presence of oxy with alkyl groups, oxygen, carbon, hydrogen, again tertiary alkyl groups. So this is what the chemical compounds which we are using as antioxidants in the food. Now, so far we talked about what chemicals in the food. Now we talk about what exactly history used in the especially definitely we all will be using soaps and detergents. So especially soaps. The question comes, what exactly soaps? Soaps are sodium or potassium salt of higher carboxylic acid, such as stearic acid, formic acid, and uric acid, whereas detergents contain a long chain of alkyl groups. Alkyl groups are nothing but as you know, CH3 groups. It will be containing long chain of alkyl groups. So detergents in comparison to soaps can also function in hard water. Some soaps are not going to work in hard water because of the presence of magnesium as well as calcium. So because of presence of calcium and magnesium, uh, the water the quality of the water is going to become a bit hard, and thereby the function of the soaps is not going to work out over there. Again, saponification, like how one can prepare the soap. Alkaline hydrolysis of triester glycerol to form soap is known as saponification. Like this is the mechanism how to prepare soap like that. So soaps do not function in hard water since they precipitate in it. Precipitate in it in the sense they are not going to react with each other. Like calcium, because of presence of calcium and magnesium, they are not going to allow them to react very properly. So thereby precipitate is going to become. Precipitate is nothing but what? Hard, solid kind of substance. They are not going to mix with each other. It is like a flaky kind of thing. So, probably you might have already experienced that one. When you are taking bottled water and when you are using soaps, there you cannot find any froth. You cannot find froth because of hardness of the water. Again, if you look into the types of soaps, we can find various types of soaps. One is toilet soaps, floating soaps, transparent soaps, medicated soaps, laundry soaps. Of course, this here all we can find the presence of chemistry. Of course, in toilet soaps we can find the presence of potassium. Again, in floating soaps, these are prepared by beating the soap bubbles. Again, transparent soaps like this contain soap dissolves in excess of alcohol. Alcohol are nothing but what? The presence of hydroxide. So the excess amount of the soap is dissolved in alcohol. So then it is evaporated. So thereby we can find the we can make the formation of transparent soaps. Next is medicated soaps. Medicated soaps, name itself indicate, we can find the presence of little amount of Dettol or Savlon in that soaps. So that's why the name has been given medicated soaps. Next, laundry soaps. In laundry soaps, mainly it contains sodium arosinate as well as borax. So in these soaps, how many chemical compounds we already seen? Plenty of chemicals, plenty of compounds we already seen in this type of soaps. So again, now we are very eager to know how exactly these soaps really works in water. If we look into the structure of the soap molecule, especially the soap molecule contains what? One is, a tail nature and another is head. Head and tail nature will be there in the soap molecules. And one end of this is hydrophobic in nature and the other end is hydrophilic in nature. What happens when the oil droplet is there means that the soap molecules is going to interact with the oil droplets, and here you can see soaps are generally sodium or potassium salts of long chain fatty acids. Soap molecules have a hydrophobic as well as hydrophilic part. Hydrophobic is nothing but what? Water hating component, and hydrophilic is nothing but it is water loving part. So when this water hating part and water loving part is there in the same domain means what happens that time? Going to interact with the dirt particles or any dust particles which is there on any cloth or anything. So while the hydrophilic part clings to the water when washing, so then hydrophobic end clings to the dirt particles, means hydrophobic, whichever the water hating particle is there, that is going to attach with the dirt particles. So when we pour away the water, what happens? Along with the hydrophobic molecule, the dirt particles also wash away with the soap molecules. So this is how actually the soap is going to interact with the dirt particles. And thereby we can find the cleaning of the cloth or any something. Again, so now we have seen what the chemicals or the chemistry of foods, then in cleansing agents. Now the turn is cosmetics. Like in all cosmetics, we can find the presence of chemistry. Example, emulsifiers, then preservatives, then thickeners, then emollient, then glimmer as well as shiners. Again, if we take these cosmetics, we can find here. These are the various personal care products. I will let you know. So emulsifier nothing but what? These increases stability of the emulsion. For example, potassium cetyl sulfate. Again, preservatives. These are added to cosmetics to increase their shelf life. For example, benzyl alcohol, salicylic acid. So this is also comes under the category of you know synthetic organic chemistry part only. These benzyl alcohol as well as salicylic acid comes. Then thickness. These given an appealing consistency. For example, cetyl alcohol, stearic acid. So these are the chemical compounds which are used in the thickness. Then emollient. These soften the skin by preventing water loss. Example, glycerin, zinc oxide. Probably these things will be using by everyone in order to make the skin as very soft from the water loss. At that time we can use this glycerin as well as zinc oxide components, which is there in any commercially available products. Again, glimmer as well as shiners, for example, mica, bismuth oxide. So these are all chemical compounds which we can find in the cosmetic. Again, if you take deodorant, mouthwash, shampoo, talcum powder, shaving cream, toothpaste, in all these things, we can observe the presence of these cosmetics of the following categories of chemicals. Again, if you take, this is very well known to everyone, especially for girls. So, as we one more thing we need to understand from this cosmetic, especially about this lipstick means, I know lipstick has contained the lead. Recently, the study has revealed that the presence of lead, which really makes adverse from health. Especially in China as well as Japan, the disease the rate has been increased more because the people there they used to use in ample quantity. That's why the lead has been they consumed part by part. No, it's not a one-time showing this one. When you take the more consumed, this lipstick now this is what happens. The very minute quantity of this lead is going to accumulate in the liver. Once this lead is going to accumulate in the liver, what happens? The functioning of liver is going to get vanished or that is going to get fails to work very properly. So once if any organ is going to fail in our body, definitely that leads to some other diseases. So at the end, it leads to that only. So that's why, again, we can find the presence of lead in this lipstick also. Again, in eyelashes as well as nail polish. Like I have conclusion based on volatiles or intersection iron oxides. You can find the eyelashes. Again, in nail polish is made up of lacquer and consists of polymers, solvents, plasticizers, colorants, and perfumes. So all these chemical components you can find in the nail polish. So again, one more part of this cosmetics comes under the category sunblock as well as sunscreen. Probably we can use, especially in summer season, probably we all will be using this sunscreen or sunblock. How exactly this sunscreen or sunblock does work? If you look into this sunblock or sunscreen, there are two kinds of rays from the sun, which are particularly bad for us. That is ultraviolet rays A and ultraviolet B rays. Sunscreen action means, as the name suggests, it functions as a screen and offers protection from sunburns, which is caused by the ultraviolet B radiation, whereas sunblock has more reflective nature and blocks both ultraviolet A radiation as well as ultraviolet B radiations, means which blocks the radiations. The rays will not go penetrate into your skin. In order to prevent their penetration, this sunblock or sunscreen helps to absorb this both kind of radiations. So this is how one can prevent the penetration of the harmful rays into the skins. So this is all about personal care, cosmetic things. And now if you see the cleansing agent, or definitely we all will be using this kind of cleansing agent. And in this cleansing agent, definitely we can find the presence of chlorine. A very common component in cleaning the product is chlorine. Chlorine has gaseous elements that can be either in large quantities or released into the atmosphere. Means, as I told you, if any element or any constituent is more than the average concentration, that definitely leads to very harmful diseases to the human. In the similar way, this chlorine also, when we are using this cleaning agent in a more amount, the particle or any chlorine which is present in this compound, it is going to react with the atmosphere. Again, it disturbs the whole entire nature of this atmosphere. Again, the chlorine can be seen from this cleansing agent. Again, Yeah, of course. Again, we can find the presence of alkalis. Then we can find the presence of acids. Again, we can find caustic soil cleaners can cause severe burning if soil or put on the skin because these all can contains alkalis and acids. Because of this reason only, we feel very itching in nature or something burning kind of thing is going to get happen as soon as if it falls on our skin. We feel like that because of the presence of alkalis or acids. So here all we can find the presence of chemistry or chemical compounds. So far we have studied the chemical in food product as well as chemical in clean living. Now let us see chemical in medicine. Because once if we take these chemicals in food, once if we use these chemicals in clean ingredients, definitely the medicine will also take a major role of this chemistry part. About chemistry in medicine, we look into the chemistry of medicine, especially blood analysis test is we are going to perform the blood analysis to know the amount of potassium as well as sodium in our blood. So how is that chemistry? Again, there are plenty of departments, especially chemistry departments as well as hospital medical labs, analyze blood, urine, etc. for protein, sugars, and other substances. So this is very common these days because due to corona, like any person visit hospital means they take blood only or any other constituents from the human. Like we need to check that part, we need to check this part like that. Like of course, this all comes under the category of chemistry only. Again, in order to cure anything or in order to prevent some from diseases means that time we definitely are going to use drugs. And especially we cannot call drug if you are not meeting or which is not going to meet these criteria. It should not disturb normal physiological processes as well. It should be harmful or should not harmful for organisms. It should be minimum as well as that's outside side. Means it should the air drug inside that should go and react with the specific locations where exactly the harmful agent is there. There only it has to go and it has to act with that one. It has to destroy that organism or any microorganism. So, but because of various side effects, side effects is nothing but what it is not going to exactly release into the affected side. It is going to create some other part, and the side effect is going to get occurs. So basically, in order to call it as a drug, this is the minimum criteria that should drug has to obey. In that one, how exactly, like catalytic action of enzyme, how exactly takes place means with the help of image, I would like to explain this thing. So first, we can find the presence of enzyme. In this enzyme, we can find the presence of active site. Again, substrate, we can find the presence of substrate. This substrate is going to react with the enzyme, active site, and thereby complexation is going to take place. So this is how drug as well as enzyme is going to interact with each other and make complex. So this is how actually drug enzyme interaction takes place. This is the drug, this is enzyme, where we can find the presence of active site. Again, drug substrate. The picture says a lot over here. Drug is going to interact with the enzyme active site. Substrate is also going to like competitive nature. Drug blocks the active site of the enzyme. Here, drug blocks the active site of the enzyme. Drugs with natural substrate for attachment of the active site of enzymes, such as are called competitive inhibitors. So this is how actually drug enzyme interaction takes place within the body. Again, what happens sometimes drugs are not going to exactly attach to the active site of the enzyme. So thereby it is going to form what happens. Some drugs do not bind to the enzyme's active site. These bind to a different site of enzyme which is called the allostatic site. Here we can see allostatic site. This binding of inhibitor at allostatic site changes the shape of the active site in such a way that substrate cannot recognize it. Means that the shape is not going to very proper. So that time when we are using direct drugs, so the drugs are not going to combine with each other. So thereby what happens? The active site with a change shape will be occurs. So thereby the interaction or complexation occurs with the having no any effective results. So this is all about how the drug is going to interact with the enzyme within human body. Again, some few drugs especially, and if you can use in the mental disorders, because in these recent years we can see the consumers of these medicine, especially mental disorders, is becoming increasing like anything. Among all those things, one is tranquilizers, and another is antidepressants, and another one is sedatives. So these are the chemical compounds or drugs, we can call it as. In all these drugs, what happens, there is some particular chemical components we can find, especially tranquilizers acts as what, reduce stress and anxiety. So this antidepressants makes very calm and very cool. By taking these medicines, the one can feel that one. And sedatives, which really improves the sleep, like which increases the sleep inducing kind of things, is going to uh, makes these sedatives. But all these drugs which are having their own side effects. If you see tranquilizers, these tranquilizers, of course, the chemical substances used to relieve or reduce the stress and anxiety, leading to calmness, are called tranquilizers. Again, the side effects. See, this is the chemical component which is present in the tranquilizers. Side effects of these tranquilizers is headache, weight gain, blurring of vision. So this is all about side effects of um, tranquilizers, and this is the chemical compound which is present in the tranquilizers, that is Valium and chlorodiazoprocoxide. So these are the chemical compounds which is present in the tranquilizers. Again, sedatives, as I told you, that sedatives are the one which improves or induces the sleeping. So in order to prepare this barbituric acid, that is inducing the sleeping, we are using urea as well as malonic acid. With the help of these two compounds, one can make the formation of barbituric acid. So this is also a chemical compound. Again, antidepressants, as told that. So these are the drugs reduce the depression. So these are the chemical compounds you can find in the antidepressants. One is iproniazid as well as phenolazine. Again, picoline. So these are the various chemical compounds or chemistry we can find in day-to-day life. So in daily routine of the man, we see this daily routine. Once we wake up, we are going to front of mirror, then again we go for to make up the pressure. So that time we're using various chemistry or chemical compounds. Again we take some free rest. For a moment we used to take rest. Again, the person goes to his room, they are going to start the days by reading to dress up. Again, we see the dress, again colors, you can various colors of dress, you can see the chemistry. So, again, you want to be the water fresh. Used to go for office with the help of the vehicles. Again, in vehicles also we can find the presence of road, that is also one of the chemistry. Again, if you work more work in office, again, the depression or anxiety, or relieve that anxiety, doing exercise has to be done. Doing exercise is weakness. Again, once we find the exercise, the person used to take, bath, again, they used to go for sleep. Again, this sleep only comes when everything is very normal. If we find any one single component is not being properly used, definitely that time, of course, we may get sleep, but definitely the person is not normally healthily working like anything before. So this is all about in day-to-day life. We can see the presence of chemistry as well as chemical compounds. So this is all about the chemistry which is present in day-to-day life. So if you have any doubts till now, this is all about fundamental aspect right now I explained. So if you have any doubts between this part, you can ask me. Or else, Nikoman, should I have still time?
Yes, sir, you can.
Are you good at typing, right?
Yes, sir.
Okay. So far I have explained about what the presence of chemistry or chemical compounds in day-to-day life. This is all about fundamental aspect. Hope you can see this screen right now. Yeah, you can see screen right.
Yes, sir.
Yes, sir.
Okay. Oops. Yeah. So till now I have explained about only fundamental part. So now slightly we'll shift into the applied part. Means applied is nothing but research oriented part. So as I told that from all these things like here we have taken we used food which contain chemical. Again we used medicines that is also contain chemical compound. Again we again used cosmetics. There also we can find the presence of chemistry or chemical compound. But especially in chemicals or in food, as soon as we take more food, the presence or concentration of the some ions or some molecules or some compounds is going to accumulate in more number or more concentration. So once if it is going to accumulate in more concentration, means what happens? So the disability of the normal functioning of the organs is going to get failed. So in that one example, with the help of one applied oriented research part, I can explain now. So first and foremost, I'll be taking biomolecule. So of course, biomolecules, as we all know that, which contains a deoxyribonucleic acid. In that deoxyribonucleic acid, I will be concentrating only upon adenine and guanine. Adenine and guanine. Why this is very important? Adenine and guanine are important bioanalytes and involved in the construction of DNA, RNA, and other biologically significant species. So, abnormal concentration of these biomolecules affects the activities of catabolic, anabolic interconversion of enzymes and thereby causes various diseases. So now we are very much interested in finding out this adenine and guanine with the research-oriented view. What happens if adenine and guanine fails to work very properly, or the concentration of adenine and guanine, you know, less concentration is there in the body means. So these are the various diseases we can see. One is the normal brain and Alzheimer's diseases comes if adenine guanine concentration comes less, or we if you are not finding any presence of exact or optimum concentration of the adenine guanine is not there means. So that time we can find the presence of various diseases. It leads to Parkinson, then it leads to cancer, then again it leads to a skin condition like diabetes. So these are the various diseases we can find if adenine guanine is not present in the optimum concentration. So now the question comes, how one can determine this adenine guanine? There should be some technique should be there, right? Like in especially there are techniques called spectrophotometry, then electrophoresis, then liquid chromatography. These all mostly some common methods are there to find out this kind of biomolecules like adenine and guanine. But what happens? They require some sophisticated instruments and a skilled person to operate this kind of instruments, and it is very difficult for routine use. Again, in order to prepare any samples, it requires a long time. It means prolonged sample preparation procedures is required for to prepare this kind of samples. Is there any other alternative to these methods? Yes, that is electrochemical methods. Why electrochemical methods? Now the question comes. Because these are very simple and cost effective, clean and green, selective and very sensitive, mainly applicable to field analysis as well as this low detection. It means we can find up to femtomolar level. If the adenine guanine, which is there up to very femtomolar levels, so till that part we can find out using this electrochemical methods or electrochemical sensors. Now I will explain how this electrochemistry works in order to sense or in order to quantify how much amount of adenine and guanine which is there in the solution. You can see this the potential charge. This is electrochemical instrumentation tool, and this is what we can call it as a 3 electrode based electrochemical cell. and which is being attached to the potential stack. Mainly we can find the presence of calomel electrode or counter electrode, working electrode, reference electrode. These all three channels have been attached to this potential stack and which is attached to the personal computers. And once if you get any chemical reactions takes place over in this electrochemical cell, so that can be seen over in this laptop in this view. If any elements which is present in this one, like say for example, now we'll be taking example of adenine guanine only. If adenine is going to takes place, oxidation reduction takes place at the electrode interface means we can find the presence of oxidation reduction reactions like this. Okay. Next is working electrode. Electrode is nothing but what? It's which conducts electricity. And this working electrode, if you see the surface of the electrode, which is modified with various kind of materials. See, we can use platinum electrodes, lithium carbon electrodes, carbon paste electrodes, so many things. Again, which contains surface. That surface will be modified with the single walled, multi walled carbon nanotubes, graphene, and various substrates. We can modify with these substrates to this working electrode. Again, reference electrode will be there. Reference electrode we are using in order to prevent the applied potentials to be constant. For that reason, we are using these three things. So this is what the exact schematic representation of electrochemical sensor working platform. Once any of the adenine guanine which is attached to the electrode surface like this, what happens? It is in +2 state. If say for example adenine is undergoing reduction step, what happens? Reduction is nothing but what? Gaining of electrons. It is attached to this one. It will be given electrons from this working electrode because in working electrode, as we know that graphene will be there or any carbon containing compounds will be there. As we know that carbon is going to give its electrons to the substrate or any analytes, especially adenine guanine. So thereby it is going to form as a phase double layer like this. Once the attached adenine or guanine exits from this surface means we can see the which is we can call it as a differential pulse photometry. How much amount of the adenine or guanine strips off from this electrode surface, that much current we can see. This each current says that the amount of adenine or guanine which is attached to the electrode surface. So by this we can say that how one can quantify, how one can exactly say the amount of the adenine or guanine which is present in the cell like that. So for that we need to prepare some nanoparticles. That nanoparticle is nothing but as I told you that here we are using graphene, right? Instead of taking graphene, we have taken nanoparticles. So that is also comes under the category of nanotechnology. Again, chemistry only. So that nanoparticle we are going to prepare with the help of ammonium nitrate as well as ferric nitrate with the help of sucrose as the oxidizing as a fuel. So we would be able to get the nanoparticles powder. Like this we used to get the nanoparticle, and once we prepare the nanoparticles we go for various characterizations. One is XRD, X-ray diffraction pattern. This gives the exact the layer by layer structure of this compound nanoparticle. Again, transmission electron microscopy. This gives the idea about the particle size, and the crystallinity nature can be done with the help of this HRTM as well as the FTIR. FTR gives the what presence of bonds or presence of various elements, like how they are exactly attached to this nanoparticle. So with this help we can tell that the nanoparticle has been formed or not. Once if we form, we can use, as I told you, that electrodes. So these are the various fabrication steps of the screen printed electrodes. This is what screen printed electrode, and this is the how one can prepare the screen printed electrodes like this. We can prepare. These all have been done in the laboratory. So whatever nanoparticles we have synthesized in the laboratory, which is going to be put over this working electrode surface, here we can see, and this acts as what counter electrode, and this is reference electrode. So all three electrodes can be seen in a single chip. This is the advantage of this screen printed electrode, and this electrode setup as I told you. So this is the what, as I told you, oxidation reduction. Like when you're using electrodes in the presence of adenine and guanine, it is going to show their activity. So with the help of this one, we can measure the presence of adenine as well as guanine. Here we can see this is for guanine as well as adenine. These are the electrochemical response in presence of adenine and guanine. We have conducted in various buffer solutions like guanine, adenine has been given a very good response in the phosphate buffer solution. That's why we have chosen phosphate buffer solution. Then again, we have been used in the, as I told you, that differential buffer to know the exact amount, how much amount of the adenine or guanine has been attached to the electrode surface. So that much amount only shipped off to the electrochemical solution. So thereby we can able to get this kind of electrochemical responses. Individually we have measured as well as simultaneously we have measured. In both the cases, the prepared material is working like very selectively. Again, we have studied in various pH solutions like pH 5.88. In biological condition only, physiological condition only, we found very good results. So this is all about calibration graph. Calibration graph is nothing but with the increase in the concentration of glutamate, the current has also got increased like this. So now we have keep on added adenine. With increasing the concentration of the adenine, increasing the current has been occurred. Now we both added simultaneously, guanine and adenine. When we added it continuously, we got increasing the concentration of the adenine and guanine. We found the increasing the current also. So this tells the nature of the proposed nanoparticles. And these are the various scientists over the globe they have prepared and they used for the selective detection of this adenine and guanine. And we also prepared, and compared to the all methods like detection limit of our prepared material showed very less detection limit. So this is one part of research work we have been carried out for the detection of this adenine and guanine. So in order to see the amount of adenine and guanine, we have taken two samples, like one is milk powder as well as urine, and we found very good result with the help of this prepared material only. And in conclusion, what we can say that this is very simple and rapid strategy for the fabrication of nanomaterial, and simultaneous measurement can be done. Achieved wider working linear range, good stability, and acceptable reproducibility. Apply to real sample matrices and achieve good recovery. And part of this work has been published in widely published in the electrolysis journal. The same work has been published in this journal. So with this, I would like to conclude my talk, and I really appreciate and I really acknowledge to my HOD, that is Dr. C.S. Kankal sir, and all faculty of members of Department of Chemistry. Again, I would like to acknowledge Dr. Mallappa, Dr. Hirantaniya, and Dr. Ashok Ayas, as well as Professor Pragibans, who has provided this screen printed electrodes. So now we can say that chemistry is all around us, but the thing is we need to observe it carefully and notice everything around us. We should appreciate the work of scientists who observe those things and brought it till us. Thank you. Yes, over to Deepa ma'am.
Thank you, sir.
So this is all about my fundamentals to applied oriented things I have covered in today's webinar. So any students, if they are having any doubts, they can ask me.
Okay, anyone want to ask the questions, you can write in the chat box.
Yeah, that is also fun.
someone told you cover all the chemistry uses in all the fields.
Yeah, yeah. Thank you very much.